chuties! This is true to Roxette Shanice B. Alarcon of grade 11 Stab del Mundo. Today, you'll learn about continuity of a function. We are going to assess if a function at a certain point is continuous or discontinuous. Moreover, there are three types of discontinuity. For you to understand more, take a look at these graphs. This is an example of a continuous function. As you see, the line is continuous. There's no gap nor a removed point there. It's just a simple line. As I said earlier, there are three types of discontinuity. First, we have removable. As you see, it looks discontinuous since there's a hole that shows that a certain point in the function has been removed. Next is jump discontinuity. You could see here that the functions look actually jumped from a certain point to another. No wonder why it's called jump discontinuity. Lastly, we have infinite or asymptotic discontinuity, and the graph tells why. There are three conditions to consider a function to be continuous. First, f of c must exist. 2, limits of the function as x approaches to c exist. Number 3, f of c and the limit of the function as it approaches to c must be equal. These conditions are hierarchical. If one collapses, others will follow, and it's called discontinuous. In removable, condition 2 must exist, and either condition 1 is DNE or 3 is not satisfied. In jump, condition number 2 must be DNE. It customarily occurs in a piecewise function. Let's try some examples now. What is f of x equals 9x minus 27 if x is at 5? Since x is 5, we just have to directly substitute it. As you see, it exists. The process is the same with limits. 9 times 5 equals 45 minus 27 equals 18. They have the same values, so condition number 3 is satisfied. Thus, x is continuous at point 5. Let's go to removable discontinuity. f of x equals 5x plus 10 over x squared minus 4 at x equals 2 and restricted to be 2. Since x cannot be equal to 2, it means that there's no point existing there. So, it's non-existent. The limit is undeterminate, that's why we factored it out before we cancel the similar terms. Still, x cannot be equal to 2, that's why I'll manipulate it this way. Now, I'll multiply the denominator to the both sides. Cancel the similar terms and add 2 on the both sides. And we'll get the final answer of 7. But, condition number 3 is not satisfied since condition number 1 is non-existent. Therefore, x is discontinuous at x equals 2. In conclusion, condition 1 non-existent, condition 2 existent, condition 3 not satisfied. Therefore, it is removable. Next, we have jump discontinuity. For condition number 1, 6x equal to 7, we have to use the first expression. Then direct substitution and equate them. We'll get 49 over 7 and the final answer of 7. Next, we have to find the limit on the right and on the left. You know that the limit is on the right when the symbol is greater than, and vice versa. Now, let's see if there's a restriction. Since it has and x cannot be equal to 7, we could factor out the denominator so it would not be an indeterminate anymore. Next is cancellation and substitution. And the limit on the right side is 0. On the left side, we just have to repeat what we did in condition 1. In conclusion, condition 1 exists, but condition 2 does not exist. Therefore, it's jump. The graph would look like this. Next, since x equals to 4, we just have to use the second expression, which is square root of 64 with an answer of f of x equals 8. Square root of 64 or 8 is just a point, so we're only using the first expression in finding the limits. But it has a restriction. It cannot be equal to 4. Even though I use conjugate or factoring, it would be still indeterminate. For that reason, I'll use a number from the right and from the left of x equals to 4 from my imaginary table of values. From the right, I chose 4.00001 and from the left, I chose 3.99999. After substitution, we have to solve for it. So, negative 36 over 2.0000025 minus 2 equals negative 36 over 0.0000025. The denominator is part of the infinity. So, negative 36 divided by positive infinity equals negative infinity. Limits of f of x as x approaches 4 from the left. We'll do the same. We'll substitute the chosen infinite value to x and get the square root. Then we'll get negative 36 over 1.99999. minus 2. Then, negative 36 divided by negative infinity equals positive infinity. In conclusion, condition 1 is 8, so it exists. Condition 2 is the end. For condition 3, f of 4 is not equal to limit of f of x as x approaches to 4. Therefore, x is discontinuous at x equals 4. Moreover, the limits are infinite, that's why it's asymptotic or infinite discontinuity. Bonus example, let us identify if this is discontinuous or continuous. X cannot be equal to 7 here, so basically it is undefined. Because if you substitute and solve for the denominator, it will be 0, and the whole expression would be undefined. Again, the conditions of continuity are hierarchical. If one already collapses, then automatically it is discontinuous. Let's find out what kind of discontinuity it is. Next, let's solve for the limits. On the right side, it is undeterminate but we cannot factor it out as you see. So we'll use the imaginary table of values. The value I chose from the right of 7 is 7.00001. For substitution, 7.00001 squared minus 5 times 0.00001 plus 4 all over negative 2 times 7.00001 plus 14. Then we'll get 18.00000 all over negative 0.00002. Then positive infinity divided by negative infinity equals negative infinity. Next, we get the limit from the left. And I chose 6.999999 squared minus 5 times 6.99999 plus 4 all over negative 2 times 6.99999 plus 14. Then we got 17.99991 infinite over 0.00002. Positive infinite divided by positive infinite equals positive infinite. In conclusion, condition 1 undefined, condition 2 D and E because it has positive and negative infinity. Lastly, for condition 3, f of 7 is not equal to limit of the function as x approaches to 7. Therefore, x is discontinuous at x equals 7. Again, the limits are infinite. That's why this type of discontinuity is asymptotic or infinite. The graph would look like this. Hoy, hoy, hoy! Thank you for listening. I hope you learned from me. Bye-bye!